Welcome to the KV Physics Academy. Now next question. Set is A. And what is the question number? Question number is 23. And ED question. Okay. A circular loop and a square loop. They are given two type of nature. Square and circular. Square loop and circular loop. Okay. Now, how the same perimeter. This word is very important in this case. If the same amount of current is flowing through each of them, means current flowing in a loop as well as circular. Okay, square loop and circular both have the same current, both have flowing the same current. Okay, now the ratio of magnetic dipole moment, circular loop to square loop, circular loop to square loop. Okay, means they ask what is the ratio. Numerator is a circular loop, denominator is a square loop. Okay. Now we know that. What is the general formula for magnetic moment? Magnetic moment, m bar is equal to I a bar. M bar is equal to I a bar. A bar is a vector. Okay. And this means a area. Okay. And I is another scalar. M bar is equal to I a bar. Means whatever the direction of bar gives by a bar. Now suppose current flowing in the direction. This finger represent the direction of current. And this thumb represent direction of generally magnetic field, but here they represent direction of magnetic moment. They represent direction of magnetic moment. Suppose current in anti-clockwise direction, magnetic moment in plus z direction. Suppose current flowing in anti-clockwise direction, magnetic moment in downward direction. Current flowing in the direction, magnetic moment in the direction. Current flowing in the direction, magnetic moment in the direction. Got it? Now system is changed, area vector also change. Area vector also change. Now suppose we can take the loop, how the radius is capital R. Radius is capital R, okay. Now what is the magnetic moment for this case? M bar is equal to I a bar. Current flowing suppose in the direction, what is the magnetic moment direction? M bar is equal to this one, okay. M bar is equal to, suppose we consider this one is Z R. Z direction, then M Z cap. Okay, now. Current, both cases we get current will be flowing in the same quantity. Means we can take I here. Now system is circular. Then what is the area? Area is equal to pi r square. Simply, M is equal to I into pi r square. Okay. What is the direction? Suppose this is the direction is how much? Z cap. What is the magnitude? I pi r square. Okay. What is the relation between these two cases? Is a perimeter will be same. Perimeter in both cases will be same. Okay. Now we know that in circular case, what is the perimeter? Perimeter, yes. Simply 2 pi r. Simply 2 pi r. Got it? This is semi-perimeter. Perimeter of circular loop. Now we can find out for square loop. For a square loop. Okay. What is the square loop? Here, suppose this one is considered as a square loop. Here we consider a square loop. Okay. Now here, suppose we can consider here a side of the square loop is R. Side of the square loop is R. Then what is the perimeter for this case? Here R. Total 4R. Okay. This does not matches with these two values because here is a 4R. Here is 2 pi. Okay. It means there is a difference. Now suppose we can take here we need to pi also. Then suppose we can take the pi r. Again 4 pi r. Okay. Our aim to finding the 2 pi r. Adjust this side just like that. Getting addition of all 4 sides become a 2 pi r. Okay. Means suppose we need to take a 2. Here is a 4 sides. Okay. Then we can take the half. Pi r bar 2, pi r upon 2 for one side. Second side, pi r by 2. Next, pi r upon 2. Next, pi r upon 2. Suppose all side we can take like that. Pi r upon 2. Okay. Addition of all 4 terms. This is equal to how much then? Addition. Pi r upon 2 plus pi r upon 2 plus pi r upon 2. How much? Plus pi r upon 2. Half plus half plus half plus half. 4 half 2. Okay. And this becomes simply 2 pi r. Simply 2 pi r. What is the semi? perimeter for this case. Which case? Square lobe. Square lobe. Here perimeter become 2 pi r. Now we can adjust the 2 pi r. At that time side become not r. Side become pi r upon 2. Got it? Means what is the side of the square lobe? Pi r by 2. Okay. Now we know that again moment of inertia. Magnetic moment, M is equal to I into A. I into A. What is the area of the square lobe? Simply, we know that. Side square. Okay. What is the side here? Pi r by 2. Then, both cases, current will be same. Then I as it is. What is the A square? A square means pi square r square upon 2 square 4. Okay. May this become 4. Okay. Now this is the magnetic moment of square lobe. This is the magnetic moment of square lobe. Our aim to finding the circular to square. Okay. Now, what is the circular? See here. What is the magnetic moment of a circular loop? Circular loop, yes. I into pi r square. What is the magnetic moment of square loop? Yes. I pi square r square upon 4. Now we can take the ratio of these two quantities. M circular loop divided by M square loop is equal to, yes, I pi r square upon I pi square r square upon 4. I get cancel, r square get cancel, 1 pi get cancel. Okay, this is like a upon B, C upon D can be written as A upon B into D upon C. Okay, means 4 coming to numerator. 4 coming numerator means this become 4 by pi. Okay, means what is this ratio? 4 upon pi. What is this ratio? 4 upon pi. Means which option is correct? Option number A is correct. Option number which one is correct? Option number A is correct for this.